Welcome to Algebra 2, Lesson 3-5, Zeros of Polynomial Functions. In this lesson, we'll be able to model and solve problems using the zeros of a polynomial function. The lesson vocabulary would be multiplicity of a zero. Let's start with model and discuss. Charlie and Aisha built a small rocket and launched it from their backyard. The rocket fell to the ground 10 seconds after it launched. And you can see that the equation is given in this form. The height, h, in feet of the rocket relative to the ground at that time, t seconds, can be modeled by the functions shown. Okay, so we can see the function here in this form, right? A t squared plus bt plus c. This polynomial is what type of function? It's a quadratic function, right? With three different terms, trinomial, if a and b and c are not zero. So let's think about these questions here. How are the launch and landing times related to the modeling function? So if this function represents the height, right, then the height is going to change depending on the time. So as time passes, we're going to have a quadratic function that goes like this, up and down, right? So it's going to be launched at this time, and then it's going to be landing here. But we know that they're going to land at 0 feet, right? And we're going to start counting from 0 seconds. But since the height of the ball depends on the person throwing, because you're going to grab the ball and throw, right? The height of the ball is not going to launch from 0 ground, right? 0 feet on the ground, right? Somebody has to hold it and throw it. So it's going to start somewhere here. So your y-axis actually should be around here. And so, yeah, this is where it actually should start. We don't know where it starts, but we know it's not going to start from 0 feet on the ground, right? And then it's going to land at 0 feet. So we start counting from here where we launch. So that's 0 seconds. And then we want to find the seconds where it fell, but they tell you, right? The rocket fell to the ground 10 seconds after it launched. So we know this is going to be 10 seconds. Yeah. So the height of the rocket is at 0. We're assuming, if we're assuming that the rocket launches from the ground. And they're not holding it. It's a rocket, right? So it's launched from their backyard on the ground. So if we're holding a ball and throwing it, then we have a height that's not 0. But if we launched it from the ground, we can count it from 0. Yeah. So then we have a graph starting from 0 in this case. So both the launch and the landing times would be at 0 and 10 seconds, and both heights would be 0 feet, right? Yeah. So the height let me type this, okay? So the height of the rocket is 0 at both the launch and landing. Which means if the height of the ball is 0, then we can plug in 0 in your equation h of t, right? And we can solve for the times, right? So 0 seconds and 10 seconds for t would be equal to 0 height. Seconds are the values of t that solve the equation 0 is equal to at squared plus bt plus c. Yeah. Let's look at part B. What additional information about the rocket launch could you use to construct an accurate model for the rocket's height relative to the ground? So what kind of information do you need more? Well, we have this equation, right? 0 is equal to at squared plus bt plus c. Ooh, this is not enough information for us to figure out the exact equation, right? We need just one more point. If we just have one more point, then we'll be able to write an equation that corresponds to this situation. So yeah, we need information about the height of the rocket. At another time, not the two x-intercepts. Or what else could help us? If we know the initial speed and the gravitational acceleration, then that could be another information that we can use to solve for the equation. But in terms of quadratic, in terms of the polynomial function, we just need another point. Okay, let's look at part C. Charlie believes that the function h of t is equal to negative 16t squared plus 160t models the height of the rocket with respect to time. Okay, do you agree? Explain your reasoning and indicate the domain of this function. So, okay, so we want to check if this is possible, right? So looking at the information we have right now, we can only check with the information we have right now. What are the information we have right now? We know that there are 2 points, 0, 0, right? And we know there's 10, 0. We just have 2 points. In order to write a specific quadratic function, we need 3 points. We need at least 3 points. But right now, we just have 2 points. So there are many possible solutions, but Charlie has come up with this one solution. Let's see if it works just using our 2 points. If it works for both points, then it should work, right? So when t is equal to 0, that's 0. Plus 0, 160 times 0. So then height is 0 too. So yes, 0, 0 works in this equation. What about 10? If t is 10, then negative 16 times 10 squared plus 160 times 10 should also equal to 0. So that's negative 1600 plus 1600. Right? So then that's equal to 0. So yes, both of our points work. So it works, right? Yeah. So let's write that in words. Yes, Charlie's model is 0 at both 0 seconds and 10 seconds. The domain is all x values from 0 to 10. Yeah. So we don't need any negative domains because we're not counting negative seconds. And we don't need any seconds that's more than 10 seconds because the rocket already landed. All right, so this is a good example for using a polynomial function, using zeros of polynomial functions to figure out a possible solution of an equation, right? So let's think about how the zeros of a polynomial function would be related to an equation and graph of the function. Let's start with example 1. Use zeros to graph a polynomial function. What are the zeros of f of x is equal to x times x minus 4 times x plus 3, graph the function. So we have 3 factors, right? Yeah, so a zero, we can call them a zero. A zero of the polynomial is a value where the function is equal to 0. So whatever x is, the value of x that makes your function f of x equals to 0 is your 0. It's called your 0. Okay, so we're calling the values of x a 0 because it makes our function value a 0. Okay, so by the zero product property, the zeros of the function are negative 3, 0, and 4. We looked at the zero product property in the last lesson. So if we have factors that make a 0, they are solutions, right? So if one factor is 0, then it is part of the solution. So the zeros divide a number line into 4 intervals because we have 3 zeros that meet the x-axis. So another word for 0 of a function is the x-intercepts. Okay, x-intercepts are the zeros of the functions. And then we also call them a lot of times we also call them solutions. Okay, so a lot of times solutions don't always mean finding the zeros or finding the x-intercepts or finding the x. Maybe the solutions are also the entire point, x comma y. But a lot of times when we're talking about solving for quadratics, the solutions are going to mean zeros of the function or x-intercepts of the function or the x values of the function. Okay, so there are a lot of words to describe the same thing, but we use it in a slightly different way. So please make sure that you understand each of these vocab words. Okay, to see how the graph of the function behaves on each interval, look at the sign of the factor on each interval and the sign of the product. So this graph could be like this. It could look like this. Or it could look like, so if this was an x-axis, it could just touch the x-axis and then go up again, right? Or it could go cross, or it could go cross. It could intersect, right? So positive could go to negative, negative to go to positive, or it could go other ways, right? Maybe it's negative here, and then it's positive here, and then it touches here, and then it still is positive here, and then it goes negative. We don't know what the shape is, but we know that the graph, however it looks like, the polynomial will touch the x-axis through the zeros. Okay, through or on the zeros. So in order to check if they're positive or negative, we check the intervals, right? So something that's less than negative 3 would be negative 4 or negative 5. Okay, we're checking these solutions, these numbers to see if it's positive or negative. So for the interval where x is less than negative 3, we check if x is negative. Yeah, it's negative. That's negative, and that's negative. So then yeah, so for example, if x is -4, that would be negative, right? If it's -4 minus 4, that's still negative. -4 plus 3, that's still negative. So if we multiply negative times negative times negative, it's a negative, right? Yeah, so this is how we can quickly check the signs of your functions. See if it's positive or negative during each interval. So anything, so pick any number between -3 and 0, and we can see if this is positive or negative, right? X is negative if it's, pick a number, -2, right? If it's -2, this is negative. If x is -2, -2 minus 4, negative. -2 plus 3 though, it's positive. So negative times positive would be a positive. So it's a positive, okay? And so far, so far we have a negative and then a positive. And then let's see where to go. This one, the next one, it should be in the same way. It's negative. Anything from 0 to 4, it's negative. So it goes through 0. And then the last interval is also positive. So it's like this. So it looks like this, where it crosses -3, 0, and 4. Your graph should be negative where x is less than -3, and it should be positive where between -3 and 0, and it should be negative between 0 and 4, and it should be positive after 4. So your graph should look something like this. We don't know how big of a curve it is exactly. Maybe it's a bigger curve, or maybe it's a smaller curve like that. But it needs to go through -3, 0, and 4 as zeros, and then you know the graph is going to be negative, positive, and negative and positive in between those intervals. Okay, so using this information, let's see if we could sketch a graph. We don't know exactly how big of a height is going to be, so you don't have to label it if we do a graph, if we sketch a graph of anything like this. Okay, so the y axes are not as important right now because we don't have enough information. Okay, it could actually be like this, or it could actually be like this, but we don't know, right? So you could just sketch without these labels, but we know zeros should be labeled, but we know that this is the right height because if we use technology. But without technology, you should be able to sketch a graph without labeling the y-axis, but you should label your numbers for x-axis. All right, so let's look at try number 1AB. Pause the video, see if you can sketch, see if you can factor it first, and then use the zeros to sketch the graph. Okay, are you ready? So first of all, factor out. You can factor out the greatest common factor for x, your GCF of the three terms, and then you'll get x squared plus x minus 6. And then you can factor that out and get x plus 3 times x minus 2, right? 3 times -2 would be -6. If you add them, it's going to be plus 1x. So that should be your completely factored form. And now, using our zeros are -3, 0, and 2, right? So using this, you have to sketch a graph. But first, you have to check your intervals. So anything that's less than -3, you plug it in here. Let's say -4, right? That would be negative, Negative 4 plus 3, that would be negative. Negative 4 minus 2, that would be negative. So negative times negative is negative. So so anything less than negative 3 would be negative. So 1, 2, 3, negative 3. So we know it's going to be negative here. And then let's check anything between negative 3 and 0. Let's say negative 1, right? So then that would be negative. That would be positive. And then that would be negative. So negative times negative is positive. So it's going to be positive from negative 3 to 0. And then 0 to 2 is going to be, let's say 1, right? That's positive, that's negative, so it's going to be negative until 0 to 2. And then it's going to be positive for anything greater than 2. So 3, if you choose 3, that's positive, that's negative. Wait, that's positive, and that's positive. So it's going to be positive times positive, so it's positive. So anything that looks like this. Sorry, the graph is kind of weird, but make sure you label your zeros clearly and obviously we should be able to tell if your graph is positive or negative between those intervals. Okay, what if it's both negative for the consecutive intervals, right? If they're both the same signs, then it should like touch the 0 and come back, right? So if that's still a 0 and it's negative here and it's negative here, then you should still touch the 0 and come back though. Yeah, but if it's positive, then you should go through the 0 and then change your sign of the graph. Okay, so there is a case where you would just touch the 0 and come back down negative, or touch the 0 and go back positive. Okay, but it's not always, your graph doesn't always go through the zeros. Sometimes it just touches it. All right, let's look at part B. If you factor it out, this is a special binomial, right? It's a square. It's a perfect square. So you can factor it out. So this is x square minus 9 square, right? So this is a perfect square. Difference of this x square minus 9 times x squared plus 9 would still be x minus 3 times x plus 3 times x squared plus 9. Yeah, but x squared plus 9, if it's equal to 0, you have x squared equals negative 9 and x is equal to plus or minus square root negative 9, so it's not a real solution. Yeah, so if it's not a real solution and you have an imaginary solution, then 3i, right? Then it doesn't cross your x-axis. You just have an imaginary solution, okay? So your real zeros, we're talking about the real zeros. Our real zeros are negative 3 and 3, okay? So if you check the intervals, you'll see that for x less than negative 4, it's going to be positive. Negative, yeah, from negative 4, yeah, that's negative, and that's negative. But then this is not a real solution, so that doesn't really matter. Yeah, but that's always going to be positive, right? Because x squared is always going to be positive. Yeah, so negative times negative is a positive, so it's a positive for anything less than negative 3. And between negative 3 and 3, you have a negative number, because that's say 0, right? That's negative, that's positive. So it's going to be negative. And then greater than 3 would be positive again. That's positive, that's positive. So from negative 3 to 3, it's negative. But for anything less than 3 and anything greater than 3 should be positive. Okay, so that should be the graph for try 1b. All right, so that was example 1. We'll continue with example 2 in the next video.